Gravity's cosmic grip. Take a moment. Feel the weight of your own body, the solid ground beneath your feet, the gentle but insistent pull that holds you to the surface of this planet. We call it gravity, and we take it for granted. We see it as a simple, predictable force that makes apples fall and keeps our coffee in its cup. But this familiar sensation is just the faintest whisper of a cosmic power so vast, so relentless, and so absolute that it acts as the universe's silent, inescapable jailer. This isn't just a force. It's the fundamental law that dictates where matter can and cannot go. It is the architect of cosmic prisons, and everything, including every single atom in your body, is serving a life sentence. To truly understand this, we need to zoom out, way out. Forget the feeling of weight on your shoulders, and instead, picture our entire solar system. See the Earth, Mars, Jupiter, all 8 planets, hurtling through the void at tens of thousands of miles per hour. Why don't they just fly off in random directions, scattering into the cold, dark emptiness of interstellar space? The answer is the sun. Our star isn't just a source of light and heat, it's a colossal gravitational warden. It has bent the very fabric of space-time around it, creating what physicists call a deep gravitational well. Our planet isn't flying the sun in a perfect circle, so much as it is constantly pursuing it, but with enough sideways momentum to perpetually miss. It's trapped in an orbit, a pathway carved by the sun's immense mass. Earth can't leave. It has a cosmic curfew it can never break. This concept of a gravitational well is the key. Imagine space-time as a stretched-out rubber sheet. A massive object, like a star, is like placing a heavy bowling ball in the center. The sheet warps and sags. Now roll a smaller marble nearby. It won't travel in a straight line. It will curve, drawn into the dip created by the bowling ball. That marble is now a prisoner of the curve. To get it out, you'd have to give it a huge amount of energy. You'd have to roll it so fast that it can climb back up the slope and escape. For planets, moons, and even us, that energy requirement is called escape velocity. For Earth, it's about 25,000 miles per hour. That's the price of freedom. That's the energy it takes to break the gravitational shackles of our home world. But even if you pay that price, you haven't truly escaped. You've just traded one prison cell for a slightly larger one. Once you escape Earth, you're still a prisoner of the sun's even deeper gravitational well. And if you could somehow achieve the colossal speed needed to escape the sun, you would still be a prisoner of the Milky Way galaxy. Our galaxy is a city of 200 billion stars, all swirling around a supermassive black hole at its center. This entire structure, this magnificent spiral of light and dust, is held together by the collective gravity of all its parts. Every star is tethered to the whole, each one orbiting the galactic core on a journey that takes hundreds of millions of years. No star can simply decide to leave. It is bound by the gravitational law of the entire galactic collective. And even galaxies themselves are not free. They are clustered together in groups, which are part of superclusters, all drawn together into colossal filaments and walls that make up the cosmic web. This is gravity's ultimate masterpiece, a universe-spanning structure of matter, a web of cosmic highways and galactic prisons, all dictated by this one silent, omnipresent force. And then there is the most extreme prison of all, a black hole. Here, gravity is not just a jailer, it is a tyrant. A black hole is a region of space-time where mass is so densely compacted that its gravitational well becomes bottomless. The escape velocity surpasses the fastest thing in the universe, light itself. Once you cross the event horizon, the point of no return, there is no escape. Not for a spaceship, not for a planet, and not for a single photon of light. All paths lead to the singularity. This is the ultimate demonstration of gravity's power. It is a force that can literally erase things from the observable universe, trapping them in a pocket of space-time from which no information can ever return. It is a perfect prison. So, while we may feel free to walk around, we are living deep within a series of nested gravitational cells. We are prisoners of the Earth, which is a prisoner of the Sun, which is a prisoner of the Milky Way. Gravity is the silent, relentless force that ensures nothing ever truly gets away. It built the universe's structure, and it holds the keys to every cell. But as we'll soon see, even if you could break these cosmic chains, a far stronger and more intimate prison awaits. Quantum bonds and freedom. Let's imagine the impossible. Imagine we could build a ship that could defy gravity's cosmic grip, a vessel that could generate enough energy to climb out of Earth's gravitational well, accelerate past the sun's influence, and even achieve the mind-boggling speed required to escape the Milky Way itself, launching into the vast, lonely darkness of intergalactic space. We find a single hydrogen atom floating in that void, truly alone, millions of light years from the nearest significant gravitational source. Is this atom at last truly free? The answer is a profound and absolute no. Because the most powerful prisons in the universe aren't the size of galaxies, they are the size of the atom itself. We've only been talking about the universe's external jailer. Now we must confront the forces that lock it down from the inside. The first of these internal wardens is the electromagnetic force. Our lonely hydrogen atom consists of a single proton in the nucleus and a single electron buzzing around it in a cloud of probability. What keeps that negatively charged electron from simply flying off into the void, leaving the positively charged proton behind? Electromagnetism. It's the classic case of opposites attract, but on a scale so fundamental it dictates the very existence of atoms. This force is fantastically powerful at short distances. The bond between that electron and proton is a cage of pure force, one that requires a specific amount of energy, a quantum of energy, to break. Without this force, atoms could not exist. The universe would be a formless, chaotic soup of unattached electrons and nuclei, incapable of forming molecules, planets, or people. Every solid object you can touch, the chair you're sitting on, the screen you're watching this on, feels solid because of the electromagnetic repulsion between the electron clouds of its atoms. It is the force that builds our reality, and it does so by ensuring no electron is ever truly free of a nucleus. But let's go deeper. Let's look inside the nucleus of a more complex atom, like helium, which has 2 protons. Both protons are positively charged. Based on the rules of electromagnetism, they should repel each other with incredible violence, flying apart instantly. The nucleus should be an impossible object. Yet it holds together. Why? Because there is another, even more powerful jailer at work, the strong nuclear force. This force is, by far, the most powerful force we know of in the universe. It is 100 times stronger than electromagnetism, but it operates over an absurdly short range, essentially only within the confines of an atomic nucleus. It is the cosmic superglue. It binds protons and neutrons together, overpowering their immense repulsion. The energy locked away within these bonds is the same energy unleashed in nuclear reactions. The power of an atomic bomb is nothing more than the sound of this prison door being blown off its hinges, releasing the energy that the strong force uses to keep its prisoners contained. To free a proton from a nucleus is to fight the strongest force in existence. It's not just difficult, it's a battle against the very laws that keep matter from disintegrating. So now we have a multi-layered prison. Gravity holds aggregates of atoms together on a cosmic scale. Electromagnetism holds the atom together, binding electrons to the nucleus. And the strong nuclear force holds the nucleus together, binding protons and neutrons into a stable core. An atom is not a single free entity. It is a complex hierarchy of confinement. But the universe has one more, even stranger way to bind things together, one that defies our classical understanding of space and freedom entirely: quantum entanglement. Imagine two particles are created in such a way that their fates are linked. For example, their spin must be opposite. If one is spin up, the other must be spin down. The strange part is this: until you measure one, both exist in an uncertain state. But the moment you measure the first particle and find it spin up, you instantly know with 100% certainty that the other particle is spin down. This is true even if that second particle is on the other side of the galaxy. An invisible, instantaneous connection seems to bind them, a subtle tether that is not a physical force but an informational one. They are not independent, they are not free agents. Their properties are forever linked, prisoners of a shared past. This is the deepest level of cosmic confinement, a connection that transcends distance itself. So, are your atoms ever truly free? From the galactic web held together by gravity, to the molecular bonds of electromagnetism, to the nuclear glue of the strong force, and the spooky ties of entanglement, the answer is clear. The universe is not a place of freedom. It is a place of connection, of bonds, and of laws. Every particle is a prisoner, bound by a silent, invisible, and utterly inescapable set of rules.